Australian researchers have successfully produced iron from synthetic Martian soil, bringing humanity closer to establishing sustainable settlements on Mars. The breakthrough, announced on Monday by scientists from Australia's Commonwealth Scientific and Industrial Research Organisation, CSIRO, and Swinburne University of Technology, demonstrates that essential construction materials could be manufactured directly on the red planet rather than transported from Earth. The research team, led by CSIRO postdoctoral fellow Dr. Dedi Nababan and Swinburne professor Akbar Ramdani, used a regolith simulant that mimics materials found at Gale Crater on Mars. By placing the synthetic Martian soil in a chamber that recreates Mars' surface pressure and heating it to extreme temperatures, they successfully produced pure iron metal at 1,000 degrees C and iron silicon alloys at 1,400 degrees C. The astrometallurgy technique employs carbothermic reduction, combining iron-rich oxides found in Martian regolith with carbon extracted from the planet's thin atmosphere. This carbon acts as a reducing agent, enabling the metal extraction process to function entirely using resources available on Mars. According to CSIRO Senior Principal Research Scientist Dr. Mark Pounceby, Mars presents unique advantages for metal extraction compared to the Moon. The red color of Mars pretty much comes because there's a lot of iron in what's called the regolith, which is the dirt and dust on the surface, he explained. The process builds upon NASA's Mars Oxygen In Situ Resource Utilization Experiment, MOXIE, which has already demonstrated the ability to extract oxygen from Mars's carbon dioxide atmosphere aboard the Perseverance rover. The Australian team's metal production technique could be coupled with future oxygen generation plants to simultaneously produce both breathable air and construction materials. The breakthrough addresses one of the most daunting challenges facing Mars colonization: the astronomical cost and logistical complexity of transporting building materials across 140 million miles of space. It cost $243 million just to send NASA's 1-ton Perseverance rover to Mars, making the transportation of construction materials for human settlements economically prohibitive. Sending metals to Mars from Earth might be feasible, but it's not economical. Can you imagine bringing tons of metals to Mars? It's just not practical, Dr. Nababan said. The Mars-produced metals could be used to construct radiation shields, buildings, and machinery for excavation, rather than relying entirely on Earth-shipped materials. The research, published in the journal Acta Astronautica, represents years of development in the emerging field of astrometallurgy. The team recently delivered a 4-day workshop on astrometallurgy in South Korea, indicating growing global interest as space agencies prepare for human missions to Mars in the 2030s. Despite the promising results, researchers acknowledge that challenges remain. We need to better understand how these alloys would perform over time, and of course, whether this